Now let's talk about the confidence interval for the difference between means. The confidence interval, again, is about showing us and reminding us that we are not making point estimates, that we should not have confidence in our point estimate. So if we go back to our original example, when we talked about the transformational versus transactional leadership, the difference between those two means was 2.03. Now, we would be wrong to say, oh, the difference in the population is 2.03. We can say we estimated it to be 2.03 based on the differences between these two sample means. And APA suggests that a more appropriate thing to do is, instead of making this point estimate, to do a confidence interval and say that given that we got a 2.03, we can be 95% sure that the populations that are represented by these two samples have a mean difference somewhere in this range. So again, the 95% confidence interval for a difference between means is the difference between the means plus or minus the critical t. Now, this is not the t that came out of your t-test. This is the critical t, right? So for 0.05 at the degrees of freedom, what would t have to have been to find statistical significance times the standard error of the difference between means? Right, again, that standard error is just the denominator of our test statistic. So it's the same concept as the one sample case, but here we're substituting the difference between means and the standard error of the differences rather than just the mean that we found. Again, this is the range of population differences from which our sample data would have been most commonly come from. So in our example that we used earlier with our transformational and transactional leadership, the 95% confidence interval would have been the difference between means, 6.12 minus 8.15, so 2.01 is the difference there. Excuse me, 2.03 is the difference there. Plus or minus 2.01 times 0.44. Now, 2.01 is the critical t. So I went and looked up, we had 50 degrees of freedom. With 50 degrees of freedom, a t of 2.01 is enough to get us to, with a two-tailed test, to p equals 0.05. So plus or minus 2.01 times the standard error, the difference between means, the denominator of our t-test was 0.44. So negative 2.03, the difference between means, plus or minus 0.844. That was 2.01 times 0.44. So the range of our confidence interval goes from negative 2.91 to negative 1.15. We can be 95% confidence that the populations from which our samples came differed in their population means by somewhere between 1.15 and 2.91. Here's what's important about this. If we reject the null hypothesis, then we should not see zero inside of this confidence interval, right? That's really a key point here. If the confidence interval includes zero, then we can say that, you know, we can't be statistically sure that there's something other than chance, because in our 95% confidence interval is the chance that the difference is zero. In our 95% confidence interval here, zero is not included, so we would say that we can be fairly sure that it's something other than zero that we finally got to. So how would we report that? We would say the 95% confidence interval for the difference between means and performance evaluation for our two groups range from 1.15 to 2.91. Since the confidence interval does not include zero, we infer that there is a statistically significant difference in the means between these two groups. We might add at the 0.05 level, alpha equals 0.05 level, or p equals 0.05 level. So that's the confidence interval for the difference between means. It's calculated very similarly to the confidence interval around the mean of one sample. Just we use the difference in samples and the standard error of the difference between means rather than the mean and the standard error of the mean.